In this video, we got 2 points and we need to find the linear equation. And we're going to look at a unique situation where one of these points is the origin. This makes things super easy, and sometimes in a application problem, you can force something to be the origin, and that makes things very easy and very quick to identify the linear equation. So we'll take a look at this scenario. So the origin, remember, is your 0, 0 point. You're on the x-axis and you're on the y-axis. You're at point 0, 0. And the nice thing about that is you already know your y-intercept, and your slope can be defined very clearly with just one point, right? Referencing that this point is 0, 0. So it's very convenient if you want to use the method that we solved earlier to identify the origin as your point 1. And you'll see why that is in just a second. So remember, when we're trying to find the linear equation, we're just defining slope and y-intercept. So if I want to set up the slope, remember it's rise over run. So if I set my 0, 0 as my point 1, this is just going to be the ratio of your y of 0.2 and your x of 0.2. So this is just going to be 5 over 2 or 2.5, right? The slope will be 2.5, positive 2.5. The y-intercept, again, we already know it because it's when there is a point on your line that hits the y-axis, and we know that point already because we have one of our points as the origin. So that's going to be 0, right? So b is equal to 0, which means I can quickly define this line as y equals 2.5 times x. We'll do the same thing for another example. This time we have the origin as our point 1, and we have -3, 4 as my point 2. See if you can quickly, with this same logic, solve for the slope and y-intercept. Okay, so hopefully this was pretty straightforward. Our slope is just going to be the ratio of our y2 and x2. So it'll be 4 over -3 or -4 over 3, right? And our y-intercept, b, again, will be 0 because we're crossing at the origin. And so our linear equation is simply -4 over 3x, as we see here. Right? So the crossing the origin, or forcing a system to cross the origin, helps us write this linear equation very, very quickly.